Today we will be going over 7.1b. So let's start with a review. How many angles are inside any triangle? And as we should know by now, inside any triangle, they all have to add up to 180 degrees. That's how many degrees are inside any triangle. Let's look at the picture. How many degrees is in X and Y? Well, we can do one of two things. First, Y. Let's find out Y. All the angles inside a triangle must be 180 degrees. To find out Y, we just do 180 degrees minus the other two. So minus 64 minus 55, that gives us 61 degrees. Y is 61 degrees. How many angles is X? Well, as we can remember, X is equal to the sum of the two opposite angles. Or we can say X is also supplementary to Y. So X could be 180 minus Y, or we can say X is 55 plus 64. Both logic works. So I'm going to do X equals 55 plus 64 degrees, and that gives me 119 degrees. X is 119 degrees. The angles X and Y form what? They are both supplementary. Notice they are on a line, so they are a linear pair. All right, let's go and classify polygons. Polygons, number of sides, 3. Well, that's a triangle. Draw it and count the number of triangles. Use diagonals. Here, a triangle is just a triangle, right? So there's only one triangle in a triangle. Try to make this thicker. Are there any diagonals in a triangle? There is actually 0 diagonals in a triangle. There are no diagonals in a triangle. And the total number of interior angles. The total number of interior angles would be what? There's only one triangle. The total number is 180. So there's only 180 degrees in a triangle. Let's look at the next one. Number of sides. Well, 4, that gives us a quadrilateral. And a quadrilateral, let's draw that. That is 4 sides. And we want to try how many triangles can we put in a quadrilateral. Well, if I cut this quadrilateral, let's say in half, I get 2 triangles, just like that. See, here's one, and I'll mark the other one with blue, 2. So there are 2 triangles within a quadrilateral, like so. I'm going to put in 2. The total of interior angles, so that means the sum of all the interior angles must add up to. So I'm going to take how many triangles there are. There's 2. I'm going to multiply that by 180. That gives me the sum of all the interior angles must add up to 360 degrees. Okay, so the next one is pentagon. And a pentagon has 5 sides. And we're going to use diagonals to cut this up into triangles. So if I took here's a triangle. So here's 1. Here's another triangle. Here's 2. So that gives us 3 triangles altogether. So there are 3 triangles. So then the total number of interior angles, the sum of all the interior angles is 3 times 180. That gives me 540 degrees for the sum of all the interior angles. Next, 6 is a hexagon. A hexagon having 6 sides. 1, 2, 3, 4, 5, 6. I'm going to try to cut this up into triangles. So I found one triangle there. There's one. Here's 2. Here's 3, and the last one is 4. So there are 4 triangles in here. So then we do 4 times 180. That gives us the sum of all the triangles, all the angles inside a hexagon. Interior angles must add up to 720. This gives us our first theorem, the polygon interior angles theorem, which just says the sum of the measures of the interior angles of any convex anagon, or just a polygon, is n minus 2 times 180 equals all the interior degrees of that polygon. Anagon just means the number of sides. It's just a generic term for polygons. Okay, try it out. Find the sum of, try it out. Use the polygon interior angles theorem below. Set up, substitute, and solve. Find the sum of the measures of the interior angles of a decagon. Remember, a decagon has 10 sides. So then that gives us 10, which replaces our n. 10 minus 2 times 180, which is 1,444 degrees. Number 2, the sum of the measures of an interior angle of a convex polygon is 900. Oh, 900. Classify the polygon by the number of sides. So now we don't know the number of sides. But I know n minus 2 times 180, well, they give us the answer. It has to be 900. So now I'm just going to simplify this to find n. I'm going to divide 180 first. So then I have n minus 2 equals 900 divided by 80. 180 is 5. Now I just got to add 2 to both sides to solve. That gives me an n equals 7. So it is 7 sides, which is a heptagon. They want us to classify it. So heptagon is my answer. Number 3, find the measure of one interior angle of the key word being regular. Remember, regular means they're all equal. They're the same length of a regular pentagon. Okay, so if I drew a regular, this isn't the best drawing, a regular pentagon. A regular pentagon, just remember from last time, all the angles are the same, all the sides are the same. That's what it means to be a regular. Well, let's put in our formula of one interior. So we have 5 minus, because pentagon has 5 minus 2 times 180. That gives me 540 degrees is the sum of all the angles. I'm going to take my 540. I'm going to divide that by 5 of them because there are 5 different angles, which is 108. That means all the angles equal 108. So this is 108, this is 108, this is 108, this is 108, and this is 108. And they all then add up to 540 degrees. Okay. Next, our polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex polygon is always 360 degrees. It does not matter what type of polygon it is. The sum of the outside will always be 360 degrees. Let's say sum. Okay, how to find a missing angle on a polygon. First, we want to see if it's interior or exterior. Next, we want to find out what the sum should be. Number 3, we want to set up and we want to substitute and we want to solve. So let's try out some of this. Let's look at number 1. Try it out. Use the steps listed above. Find the unknown angle. Okay, what unknown angle are we looking for? These ones that they have marked down here. And those angles are interior angles. So they are interior angles. The sum of those interior angles, well, let's find out. There's 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. So 5 minus 2 times 180. That gives me 540. So they have to be 540. And since these two have the same tick marks, that means they have to be the same. So I know two of them, right? X plus 93 plus 156 plus 85 must equal 540. I'm going to combine all of my like terms first. So x plus x is 2x. 93 plus 156 plus 85 gives me 334 equals 540. I'm gonna subtract 334 to both sides. I'm in the substitute and solve portion now. So then 2x must equal 206. Finally, I'm going to divide both sides by 2. X equals 103 degrees each. Like so. Let's try number 2. Number 2, I am dealing with exterior angles because these are on the outside. The sum, 360. Always 360. I'm going to set this up. That means all of these added together must be 360. So 2x plus x plus 67 plus 89 must equal 360. Combine my like terms, so I get 3x, 67 plus 89, 156 must equal 360. 360 minus 156, 204. I'm going to subtract 156 from both sides. That gives me 204. Divide both sides by 3 to finish it off. X should be 68. X equals 68. All right, last one. Last couple ones. I'm dealing with an exterior, so we are exterior, and the sum has to be 360, always. So we got that. Let's set up and solve. So we have x plus 86 plus 92 plus x plus 70 must equal 360. Combine like terms. So 2x, 6 plus 92 plus 70 plus 248 must equal 360. Subtract 248 from both sides. Gives me 112. Divide by 2. X must equal 56. Right, last one. We are dealing with an interior to find the sum. There's 1, 2, 3, 4, 5. Oh, we already did 5, but 5 minus 2 times 180 should give me 540 degrees. These two are the same. Oh, this is 90 degrees, so this is 90. So I'm going to label this x and x. So then 2x plus 90 plus 47 plus 119 must equal 540. Combine like terms. 2x plus 256 must equal 540. Subtract 256 on both sides. Divide by 2. and x should equal 142.